Here we see the same quadratic written in three different forms. First, the expanded general form, so x squared plus 8x plus 15, and then the factor form, where I've factorised that expression. There's another form that we'll look at, which is called vertex form. First, let's have a look at this sketch. So we see that the parabola opens upwards. I can see that from my general form because the coefficient of my x squared term is positive. I see the y-intercept is 15. Again, I can see that from my general term. I see I have x-intercepts at x equals minus 5 and minus 3. So they're the values that make the first bracket 0 and the second bracket 0, giving me an answer of y equals 0, which is when a graph crosses the x-axis. Next, I see my turning point, which is occurring halfway between my x-intercepts at minus 4. Then if I sub in minus 4, will I get minus 4 plus 3 times minus 4 plus 5, which gives me minus 1 times 1, which is minus 1. So now let's have a look at how this sketch relates to my vertex form. Here I see a value of minus 1. Notice how that's the y position of my vertex. The x position of my vertex is x equals minus 4. Note how that x value makes this bracket 0. So the vertex form tells us where the vertex is. So this vertex is a minimum, and that minimum value is occurring when x equals minus 4. Let's have a look at this equation again to make sense of that. So when I sub in a value for x, I add 4, then square it, and then I'm subtracting 1. So the smallest output I can get here is going to be when this expression here is 0. Because whenever I square a number, it's either 0 or positive. So if I want to make this as small as possible, well, this term is going to be 0, and I'll get an output of minus 1. So that tells me the turning point occurs when x equals minus 4, making the bracket 0, giving me an output of minus 1. In general, the vertex form is written as y equals a bracket x minus h squared plus k. The value of a, again, tells me the shape. When it's positive, the parabola opens upwards. When a is negative, the parabola opens downwards. And the turning point, or the vertex, is occurring at the point xy equals hk. Okay, so careful here that it is always written as subtract h. So if h is a negative value, like it is here, so here I see h is minus 2, that means the turning point is going to occur when x is minus 2. However, we won't write it like this, we would simplify it to x plus 2 squared. So I think of the turning point as occurring at the x value that when I sub in, I make the bracket 0. So here, my turning point is going to occur at x equals minus 2, because when I sub in minus 2, I make the bracket 0. In the general form, the turning point occurs at x equals h, because when I sub in x equals h, I get h take h, it gives me 0. And of course, if I make this whole term equals 0, well then my output is simply going to be this value k, giving me the vertex or the turning point occurring at x equals h and y equals k. Let's look at an example here where we have our relationship given in vertex form. We have y equals x minus 2 squared plus 3. So first the shape. Here I can tell if I expanded here, my x squared term would be positive, meaning my parabola opens upwards. Second, the y-intercept is when x equals 0, Note here I can't read it directly from this form because when I sub in 0, this term won't be 0, so I need to make a calculation here. So when I sub in x equals 0, I have minus 2 squared, which is 4, plus 3, giving me 7. Now the vertex is at hk, so here I see h is 2 and k is 3. I think of this as, what x value do I sub in to make the bracket 0? I sub in 2. When I do that, I get an output of 3. So sketching here, I have my y-intercept, I have my turning point, and I know my parabola opens upwards, so I can go ahead and sketch straight away. Here, if I exploit the line of symmetry, I can calculate this point over here. So again, this point is going to be at a height of 7. The x value, well, we have 2 across to our turning point, go 2 out this way, that point would be the point 47. Notice here we don't have any x-intercepts. What that means is we cannot graph this expression via factor form, because we'll find if we expanded the x minus 2 squared and collected all of our terms, we'd be left with an expression that we can't factorize. In this lesson, we're just going to be looking at situations where we're given the expression in factor form or fairly close. Okay, so we're not going to be completing the square this lesson. So, for a few examples to make sure you understand, for each of the following quadratics, what's the vertex and the number of x-intercepts? So for our first example, the vertex has the x value that when I sub in that value it makes the bracket 0, 3. When I sub in 3, that goes to 0 and I get an answer of minus 5. Now, how many x-intercepts will that have? Well, a very rough sketch. My turning point or vertex is at x equals 3, y equals minus 5. So it's down in this part of my sketch. Now, the question I've got to answer is, if I have a parabola that opens downwards, I'd have no x-intercepts. However, if my parabola opens upwards, I'd have 2 x-intercepts. In this example here, my parabola will open upwards because my dominant term, the x squared term, if I expand here, I would get 2x all squared. For my next example, x plus 1 all squared, my vertex will be at the x position, such that when I sub in that value of x, I get 0 here. So that's minus 1. If I do that, I'll get an output of 0. Here, I see this vertex is actually on the x-axis. My parabola will open upwards here. Now, because my turning point or vertex is on the x-axis, I only get 1 x-intercept. For my next one, if I sub in minus 5, I make the bracket 0. When I do that, I get an output of minus 2. Another way to figure out how many x-intercepts this will have is looking at the y position of the vertex. So here my graph is turning around below the x-axis and the dominant term is negative. So my parabola is turning around below the x-axis and opening up downwards. There's going to be no x-intercepts here. For my last example, I'll have my vertex at 2. When I sub in 2, I'll get an output of 3 here. Again, how many x-intercepts? Well, the turning point is above the x-axis here. However, I've got to be careful, my dominant x squared term here will be negative. So it is turning around above and opening up downwards. I'm going to have 2 x-intercepts here. Now let's look at going the other way. Say I'm given a sketch where I know the turning point and one other value, here it's the y-intercept. I can determine the equation of this quadratic by simply using the vertex form. So here's my vertex form. Now, my turning point gives me the value of h and the value of k. Substituting those in and simplifying, I get y equals a bracket x plus 3 all squared plus 1. However, I still don't know the value of a here. I do know that a must be greater than 0 because my parabola is opening up upwards. The greater the value of a, well then the faster it would open up. If our value of a was only just greater than 0, it would open up very, very slowly. So there's only one value of a here that will go through this y-intercept of 19. Now remember here the y-intercept is the xy point when x is 0, y equals 19. So I gave you this point in this problem because it makes it a little bit easier. But in general, I could give you any xy point and we could still solve for a. However, to find a, when we sub in x is 0, y must be 19. Let's do that now. So I've subbed in y is 19 and x equals 0. So I'll see here 3 squared is 9. So I'll have 9a plus 1 equals 19. Solving for a gives me a equals 2. This means the equation in vertex form of this quadratic is. So from this lesson, what I want you to understand is to how to find the vertex of our parabola when we are given the quadratic in vertex form. Also determining perhaps how many x-intercepts it will have.